Good afternoon. This is Gerhard Weber speaking from the Department of Evolutionary Anthropology at the University of Vienna. Some people would be online, and we are here because of a very special event, because we got the fossils from Ethiopia that we found in the years between 2000 and 2009. We got them to Vienna to be scanned here and to be investigated here in Vienna, which is was not easy task to do. And we have a very special guest here, and that is the curator of the fossil, Sahleselasie Melaku Azene. And he will give a talk afterwards, but I want to give you a little bit framework because most of you are not familiar with what we did actually in the early 2000s in Ethiopia. Some of the team is here, Bence is here, Bence Viola, Andreas Stahlmeier is here. But most of you have not seen it. What you see here on the screen currently is our area, and you see already the nice sediments. Yeah, you might have seen sediment pictures from other locations in Kenya or Tanzania and Ethiopia in the Awash, and we have similar situation here. And the area is called Galilee because of this tabletop mountain. Oops, this one is working. You should also see that online. So that's a tabletop mountain. It's called Galilee, and the whole area is named after this mountain. That's a typical situation from the field. So we were mostly walking through the desert. It's very hot there, between 35 and 40 degrees in the shadow, but there is no shadow. And you find eventually fossils on the ground. Sometimes it looks like this, or like this. The whole group is looking in the sand for fossils because that was a spot where we were expecting more to come because we found other fossils. So it's a pretty tough job. There are big elements like this and an elephant tooth, so that's easy to discover. But there are tiny things, and here is the discovery, our first discovery. Here you see our first tooth of an Australopithecus. We think it's a forensis. You have already identified it? Yeah, most of you have, but yeah, it's this one. But it's not so easy if you are walking already since 5 hours in a very hot environment and staring on the ground and try to find fossils. Sometimes we did also a real more what you consider excavations. So we had some grit, and we were digging into the soil, into the sediments here, but that was rather rare, only in areas where there was a high density of fossils. That's one of the typical pictures about how we look after the field work, and in the background you see already a sandstorm coming. So that's also some events we had. Or we got rain and the cars got stuck in the area. And there are local people, they are called Isa. And these Isa people are nomads. And in the Somali region, we're talking about the Somali region here of Ethiopia, that's in the far east of the country. And these people have a really tough life. They're out there the whole year with some cattle and some very rudimentary camps that they built. But they were, of course, very interested in what we are doing. And so there was some exchange also with these local people. And that's one of our guards. We had always had to have 20 guards with us. And you see already the known AK-47. So AK-47 was always with us. And nobody left the camp without AK-47. And usually we had 5, 6, 7 of these guys with us when we were in the field, because it's not one of the most safe areas, I would say, in the world. So this was also a challenge. That's our geologist, for instance. Also, these things happen. He's drilling to get some material for paramagnetic dating. And this is why we have been there. This is a photo that was just made. 9, where we got 10 so far, 10 teeth of Australopithecus, probably also something else, which was earlier, but that's on the way. We have to study it more carefully. But these 9 teeth, you see, most of them are quite well preserved, all between an age 3.5 to more than 5 million plus is the age. So very interesting time that we cover in the area, because that is the time where it shifts from Ardipithecus to Australopithecus, and the onset of Australopithecines, Anamensis, and then Afarensis. That's was the first tooth that you saw at the other slide, that you identified on the slide, called GLL33. That's the only one that is already described in the paper, and the rest is now to come. And that's our star fossil, that is GLL888. As you see, it's a proximal femur fragment. It's one of the bigger pieces and very interesting from its time, and also the onset of bipedality. And Bence found it in the field. I have no photo yet. I don't know if, yeah. Bence is our best fossil hunter, but also Andrea found several. Yeah. He found more teeth, but not such a big thing as you. So that's the reason why we are there. Okay. So that's it as the background, and I want to introduce now Sahle. We just call him Sahle, but his full name is Sahleselasie Melaku Azene, and he is the head of the department for paleontology and paleoanthropology, and for the collections at the Ethiopian Heritage Authority in the National Museum of Ethiopia in Addis Ababa. So he is responsible for all these fossils, and he's also doing a lot of work in the field. He got an bachelor degree in archaeology and heritage management from Addis Ababa University, and he got a master degree in paleoantro and paleoenvironment, also from Addis Ababa University. So he will give a more summary talk, not talk about Galili, but a more summary talk about what happens in Ethiopia. But he himself is interested in taxonomy, paleontology, and evolutionary dynamics in the Neogene. So that's the Miocene and Pliocene, exactly the time where we also work, and has an emphasis on Bovidae, the Bovidae family. He's very actively involved in fieldwork, so he's also going out with all the other teams, the famous teams into the field, like Team White and Sahleselasie and Johannes Sahleselasie and all these guys. So he's very familiar with the situation in his country, and he's doing actively this field work, and also specialist for HEAS.
Thank you, Gerhard, for the warm introduction, and thank you for welcoming me to the University of Vienna to give this talk, and thank you, Andrea, for organizing this talk. So my talk would be a brief summary of why Ethiopia is designated as a cradle of humankind. The title of my talk would be Deep Rooted in the Rift, Ethiopia, the Cradle of Humanity. And we all are familiar with the Great African Rift Valley, which is this area right here, which extend from Syria all down to, I would say, South Africa. And the Afar is particularly very interesting because of these plate tectonics. So there are 3 plates that are pulling apart, which is the Nubian plate, the Afar plate, and the Somali plate have been pulling apart for over 10 million years. And these have created and exposed over a kilometer of sediment in the region, so that we are now luckily finding fossils in that region. And I would say over 90% of what we know so far have been discovered in this region. But not only in the Afar region are things are discovered, also things in the southern part of the rift have been, some of the things have been discovered, except South Africa, which is a cave system. But if you see in Kenya and Tanzania, which are also part of a rift system, most discoveries have been found there. Oops. So as you can see from this map, this is the rift axis going through from the north to the southern rift portion of in Ethiopia, and all the sites that you see here, all the famous sites that you know today are found all the way from the southern section to the northern part, which are actually divided in three main sections, which is the Afar rift right here, and the main Ethiopian rift right here, and the what do you call the broadly rifted zone of the southern rift, which also partly extend into the Kenyan rift. And all the discoveries that we know today in Ethiopia came all through these regions. And today in Ethiopia, we have, I would say, over 13 species of early human ancestors. Over these 13 species, only one was not known in the Afar region, but recently there was a paper published by Zorasan Nayalabsagar and colleagues, and the Paranthropus was also recognized in the Afar region. So now the map is complete for the Afar region. So all the species that you will see here are being discovered in the Afar region, also in the southern section of the Great Rift Valley. So as you see from this phylogeny, we have from over 6 million years to the recent Homo sapiens fossils. We have over 6 million years of record of human evolutionary history. But there are obviously many gaps that we doesn't really understand. For example, some of the question marks you see here in this phylogenetic tree have been not adequately answered, but I would say there are more fossil discoveries have been going on. And as you know, the scientific process is very slow. So we are finding fossils and currently filling this gap as we speak. And Ethiopia is so unique in terms of paleontological record. This is due to the fact that we have over 6 million years of evolutionary history that is well covered by slices of time. Over 6 million years of span of time have been discovered in Ethiopia, starting with the earliest human ancestor that is here, Ardipithecus cadaba, 5.8 million years. That represents one of the earliest human ancestor. And at 4.4, we have Ardipithecus ramidus, and all these species that you see here in the Middle Pliocene, which I'll briefly go through in the next slides, are also being discovered in Ethiopia. And also the only, and I would say the crown Homo sapiens have been also discovered in Ethiopia, which is Homo sapien idaltu. So that represents we have both ends and all the points in the nodes, I would say, for human evolution in Ethiopia. So speaking about human evolution, one of the founding fathers or the key players in African, sorry. Oh, oops. Did I go back? Is this man right here, which is the discoverer of Tuang child in 1983, which is Raymond Garth. And during this time, Africa was not recognized as the cradle of humankind. And when Dart published his finding actually in Nature, most colleagues criticized him and challenged him that this is not the case. But later discoveries did strongly show that this is not the case. But I'll show you all the story in the next slides. And the other key players are the Likis, which is one of the reasons that research is also started here in Ethiopia. And here in Ethiopia, research started in the 1960s because of partly the Likis. The famous area of the Omo Basin have been explored also by the Likis. And during a seminar, the Emperor Haile was invited in Kenya, and he was visiting the country. And during that time, they showed him all the famous discoveries that have been made in Kenya. And the emperor was very interested in why Kenya was, the cradle of humankind, and why did they have all those fossils, but not in Ethiopia. And the Likis told them that this could be also the case in Ethiopia, and they are very much interested in looking fossils in the southern portion of Ethiopia. And they looked for quite some time, and actually they did find a couple of fossils also in southern Ethiopia. And this is how the research was initially started, systematically, I would say. But this is how, when the emperor was visiting some of the sites back in the day. And the key player actually in the first initial, I would say, exploration, not systematic research, was this man right here, which is called Armborg, which is a French explorer that did a lot of exploration in the Omo Basin from 1923 to 1933. And this man right here did wander around and find most of mammals and reptiles, and some of the stuff that the Likis were eventually continued upon and did research. So this man deserved some of the credit for the research also. And this was the later systematic work following by the French and the Likis in the southern Ethiopia. But the pioneers in this kind of research, the main pioneers is a geologist by training, which is a French geologist called Maurice Taïeb, which eventually started working in the Awash River. So his dissertation was on the studying the sedimentology and stratigraphy of the Awash. And he did documented all the modern river activities and sedimentology, all the way from the upper Awash Basin to the lower Awash Basin. And back in the day, there was no cars, no roads, so he did travel in a back of a camel, and he walked most of the areas with the local guides. And during that, he noticed some of key specimens and studied most of the geology of the Afar Basin. And this guy was the first one who initially identified the site where Lucy was discovered, which is called, for most English speaker, it's Hadar, but in the local language is called Adar, actually. And this one was the key player in this research, and was the founding father of the International Afar Research Expedition, which did most of the work, and he did also the geology and all the logistics and things like that in Hadar. And this is the team that did work in the lower Awash Valley, starting in 1972. So French were part of the team, and Americans were other part of the team. This is the one of the persons that did contributed to most of the work and hominid evolution. His name is Yves Coppens, and there is also a woman that contributed a lot in joining the American and the French team. Her job was, she was a pollinologist. She studied fossil pollen. Her name is Raymond Bonfi, and she is a key player in building this team as well. And eventually also Donald Johansen and Maurice Tayeb worked together, all the geology and paleontology at this area. And like I said, Romin Bonfi, which most of you maybe are not familiar with her work, but she did study the environment and geology of both the lower Awash Valley and the lower Omo Valley. And the first exploration also was done with Tayeb together with her assistants. And she was actually the first to invite Professor Donald Johansen to Hadar. So she was a very key player in this field. And she did describe and do the analysis and told us what the paleo environment looked like at Hadar and other places as well. And these are the other main players that tell us why the Afar, why the in general Ethiopia is the cradle of humankind. And this is the team that eventually discovered our earliest human ancestor, and this is the area that was the central attraction that drove all these discoveries until today. And this shows you that science is always a collaborative research. And another key is an Ethiopian discoverer who discovered most of these early human ancestors after Hadar. He worked starting in 1974. His name is Alamayo Asfaw. He's a very famous fossil finder, and he did discovered most of the fossils that we know today also. And he was the government representatives for a long time, and he did work in most of these fossil sites that we know today. And he's keen in discovering the AL 200-1, which is this very nice palette that tells us about the craniofacial morphology of Australopithecus afarensis. And he had a long career, and this is a recent picture of him, which continued his career until today. And this is also the recent pictures of what the pioneers look like. Unfortunately, most of these people have been now dead, except Professor Donald Johansen and Professor Tim White. And this is the overview of what the area and in terms of landscape look like. So you can one can find himself wandering through this desert and trying to find these tiny human ancestors, isolated teas and things like that. And actually getting to the sites is the most difficult part. Gerhard was showing some nice pictures how that was also the case in working in Galilee. And always this is a very challenge for most of us in getting to the sites. And sometimes, people trying to cross, big rivers like this. Sometimes water flash floods would come and submerge the vehicles, and people sometimes cross the rivers in foot like this, and you have to drive for hours where you can, and try to have to walk for all the day, trying to get to most of these sites. And after getting closer to this most of these sites, which are very interesting when we see this kind of sedimentary settings. So people, go down usually and do what he calls systematic survey, and people mostly, look this kind of gravelly surface and trying to look for remains of, fossils, usually human ancestors and other mammalian fossils as well. This is a close-up of what people usually do in the day. And if you are very lucky and try to find something like this, obviously you don't find the entire cranium sitting on the floor. You see it started something like this first, a little fragment. Then after noticing what this is, people usually sits in their hands and knees and try to find little fragments and try to find the remaining of what this thing is. And this is an early human ancestor actually of a jaw that was discovered in the Woranzo-Mille area in the Afar region. This is just to give you an example. And this is how we work. And sometimes also we sift the area. This is a video, if it can play. Yes, it can. So sometimes we also, sift the area and try to discover most of this isolated specimens and try to refit it back later in the lab. And sometimes we do also wet sieving, not also dry sieving. So if there is access to rivers, we go to the river and do what you call wet sieving and try to discover most of these fragments of fossils. And this is how this all early human ancestors, I would say, have been discovered. Most people think that, you wander around in the desert and find a skull, but that is not the case. Although sometimes in certain extraordinary moments, you can find something like that, but the chance of finding like a skull or a jaw that is complete is, I would say, 1 in a million. So this is the initial discovery that why Ethiopia did opened up and show the world that, in fact, Ethiopia and Africa in general is the origin of humankind. And if you see this one, this is a fossil called AL129-1, which was discovered before Lucy. Most people know that Lucy was the first discovery, but in fact, this was the first discovery that was done by the IARE team back in '73, and this fossil did show that for the first time that humans were walking upright in two legs over 3 million years ago. And there is a documentary that Owen Lovejoy was saying that after studying these fossils and seeing, he showed to his friend, which is a medical anatomist, and he laid out the specimen in the living floor, and he said, "This is one of the knee joints that I put into one of my patients." This is how these fossils are. This fossil is iconically much more similar than us than apes. And this is a very interesting specimen that was discovered also later in '74, which is a booming, discovery that showed the world Africa is the cradle of humankind. And this is LH4, where they did the formal description of Australopithecus afarensis. So the holotype came from Tanzania because the studies were conducted first in Tanzania, then later in Hadar. And this is the team where they did initially the study. This is an old picture that was taken in Kenya. And this were where they did the initial description of Australopithecus afarensis in Nairobi. And most of these, old faces, some of them you recognize. And Lucy, or what they call her in Amharic as Dinkenesh, which is meaning marvelous, because she is the one of the iconic fossil specimens we have that opened the door for all the findings. Now, as I showed you, even though we doubled the age of human origin research, we really don't have anything to match for Lucy. So her fame continued until today in driving many younger generation into our field. And this is the setting that I'll show you how Australopithecus afarensis did inspire a generation of scientists. And like I said before, this was the holotype of Australopithecus afarensis that was discovered in Tanzania, and you see the footprint that comes along with it. But we have most of these specimens that you see here, along with the first family, which is AL333, well, was discovered in this area, which is a very nice area, which made a lot of discoveries in Hadar. Now we have over 1,000 of fossils for Australopithecus afarensis that are stored in Ethiopia, Kenya, and Tanzania. And I would say Australopithecus afarensis is the most well-known and studied fossil record that we know ever. And we have, in Ethiopia, we have more than 500 fossil specimens for Australopithecus afarensis. And including now the 3 partial skeletons. You all are familiar with Lucy, but after her at 3.3, Professor Zarosana Alamsaka discovered another very iconic specimen called Salam at 3.3, which showed us about the ontogeny of Australopithecus afarensis and the growth and development and things like that. And Professor Johannes Sahleselasie did discover this male partial skeleton, which is called Kaddanumu, which is an Afar word which means big man. So you can compare Lucy with, for example, with this specimen, and this is twice as large as Lucy, which showed you that there is a big sexual dimorphism in Australopithecus afarensis. And I would say if you laid out all the specimens from Hadar alone, you can see the differences in size and shape is incredibly varied. And now we know about Australopithecus afarensis from all these sites, including Goranzomile, Hadar, Dikika, Midlawash, and all the way down to Laetoli. So all these sites that have produced fossil record of Australopithecus afarensis. And obviously, Lucy was not living alone. Some of us are also interested in the fauna record. And these are some of the iconic specimens that were discovered alongside with her. Some of the complete specimens like this Ugandex, which is an early buffalo skull that you see here. And this is a Sewed skull, which is an ancient pig. Notochorus uilis was discovered also along with Lucy. This is a very iconic specimen of an elephant. You can see the whole skull and all the tusks have been discovered. And this kind of animals is key in terms of understanding the paleo environment and paleoecological context for our early human ancestors. And with that, people were trying to understand why this kind of our ancestors were living in what type of setting and what did it show. And from that we can the artists with the help of the scientists, of course, can generate something like this, which is how the paleo environment of these early human ancestors did look like. And with low altitude forest, these early human ancestors preferred somewhat a drier climate. And we can see all the extinct elements in the background. This is an extinct giraffe and some of the antelopes in the background, and they were also being shown over here. And to give you a little bit about on Lucy, most of you know the skeletal anatomy. Of course, she had a small brain case, very prognathing jaws, a funnel-shaped rib cage, relatively longer arms. Although this was, much more primitive conditioning and earlier ancestors, and broad and low pelvis in her because she's a female human ancestor, and she's also somehow adapted to bipedal locomotion. And this is the reconstruction of what the locomotory repertoire of Francis looked like. And obviously you can see the reconstruction of the birth morphology of the pelvis, and obviously Australopithecus afarensis was much more capable of delivering a baby through the birth canal. And this is another key specimen that's indicated of what ontogeny of Australopithecus afarensis look like. And this is what the phylogenetic relationship looked like in terms of the Australopithecus afarensis and the other lineage that gives ancestor-descendant relationship with the later hominids like Homo habilis. Some people put it like a phyletically evolving lineage. One gives rise to the other, but now we know that it's all more of like a bush than like a line. And with all that background, what does her legacy give us to the knowledge that we have now in terms of understanding her biology, for example? So she is the pioneer for opening the doors of all these famous scientists that you see in this picture, including the famous ones, Dr. Brahane Asfaw, Professor Johannes Sahleselasie, the late Bill Kimball, Brigitte Senu, Professor Zarai. All these are an example of what she did impacted the next people of scientists in this area. And also the things that drive me here in Vienna. Also, some of the fossils that were discovered in this region also did made by a younger generation of scientists, obviously. So this is the area that Gerhard did showed you earlier in the talk, the Mount Galilee Formation, which spans over 5 million years of deposits, and did made significant discoveries. Also, research is still ongoing still. The earlier discoveries is also made here in Ethiopia. So after the discovery of Lucy, there was a little gap of understanding why actually walking on two legs, especially, was an earlier form of our adaptation, and why this was not depicted in the fossil record. And starting in 1994, a team led by Professor Tim White made a significant discovery in the Middle Awash region in Ethiopia. And they did discover a lot of early human ancestors. And in 2009, they made a remarkable announcement of a partial skeleton known as Ardipithecus ramidus. I would say this is the earliest and best known skeleton in this time period that showed us, why early human ancestors starting on two legs. Obviously, she have a very small brain case. And the touched but reconstructed pelvis did show that she was walking on two legs. She have a very long arms and a very hands that are much more capable of, climbing up trees. But the interesting thing about the hand, if you look at it closely, the morphology of the hand bones did show that this was not an animal that was evolved from a chimpanzee because her hand morphology is iconically human-like than ape-like, which is one of the most surprising discoveries about RD. And if you go down, also the foot is very, very interesting. If you see here, you have a grasping big toe, which was here, this bone is called the medial cuneiform. And the medial cuneiform was a very adaptive of walking in function that in both settings, and both in arboreal and terrestrial setting. So she's a mosaic animal that lives in both setting. And this is the reconstruction of her pelvic anatomy. And the picture up, you see also one of the most characteristic things about the CP3 dental complex, which is one of the key features that showed or that distinct us among our closely relatives, the apes, of course, is we didn't hone our canine complex, which was also evidenced by Ardipithecus ramidus. You have a very, in females at least, they have a very reduced canine tooth, which showed that these species didn't hone their canine teeth, and this is one of the defining characters of our family Hominidae. And when we see the locomotory rupture of this animal, obviously she walked on two legs, but if you can see the Homo sapien pelvis and Afarensis pelvis, and her pelvis is in transition between this group and the pan group, which is not very straight, but the ilium is much more adaptable for upright walking. Other fossil records that were much earlier in time are Ornithogenesis, Ardipithecus cadabra, and the others from Ethiopia, from a place called Adu Asa Formation at 5.8 million years. It is the earliest human ancestor, and also at 7 million we have this species called Sahleselasie chilensis. But you can see this all these fossils can certainly fit into a shoebox, and our understanding is much more limited than obviously Ardipithecus ramidus. There are newer fossil discoveries that are, being made over the years, and we expect something is coming soon. And this is the differences in the bipedal locomotion in this Sahleselasie chilensis creature. And this showed you that Lucy was opened the doors, but she's not the earliest known ancestor so far, even though she is very famous. And after that, from 1995 onwards, a lot of discovery have been made, also in Kenya and much more in Ethiopia. A species called Australopithecus anamensis was recently been described by this famous skull from the Wuranzumile area in 2019, which for the first time, for example, did show us how the facial features of Australopithecus anamensis look like. It was discovered by Johannes Sahleselasie, and did show that for the first time, because despite the fact that there was isolated, jaws and teeth, didn't really showed how the face looked like, but this gave us a first glimpse of the face. And from Chad also we have another species called Australopithecus bahar-ghazali at 3.5 million years. And people at this time period did consider traditionally this species maybe belong to one species, and there are other that doubted and gave them, three or more species. Things like, for example, Kenyanthropus platypus, that was 3.5 million, and also from South Africa, Australopithecus prometheus, quote unquote, have been also discovered and described at, they claim 3.6, but the age, of course, is very doubtful. It was from Streckfontein member 4. And also another species was named at 3.5 million by also Johannes, called Australopithecus deiremeda. And this showed you that Australopithecus afarensis was not living alone, but there might be other early human ancestors were living alongside it. Although some scientists, forcefully doubt this and lump everything together and put it in one genus and species. And recently, of course, there was also another discovery which is very interesting and did show that these species, Australopithecus deiremeda, have a very interesting locomotory rupture, and at 3.4 million years, we have a multiple mode of adaptation for walking, which strengthens the claim for Australopithecus deiremeda, and maybe more is also been underway. And not only the human ancestors, but also Ethiopia is well known for the origin of the first tools. 2.6 million years, for example, the first tools was named in Ethiopia, the oldest. Although now we have from West Turkana the 3.3, the oldest stone tools. And also from Kika, we have this specimen, which is over here, which is a bone-inflicted cut marks that was that showed for the first time that humans were accessing the marrow of animals, and doubtfully this time period have been still underway. Research is still underway, but we suspect that the first tool could have appeared during this time period. And this is again the same slide, but this slide can show you that our understanding today regarding the origin and diversity at 2.0 million years is much more bushier than it used to be. It used to be 2-3 species. Our understanding was minimal regarding the origin and distribution of early human ancestors, but we now know much more, and researches have been underway in multiple regions of Africa. And recently, of course, we all are familiar with this one, 2.8 million years. Colleagues in Ethiopia, also in the Afar region, discovered 2.8 million years, the first origin of our own genus Homo. A team led by Professor K. Reed, they discovered this Joe. And following that, there was also a recent paper that showed there might be another later appearing species between Homo and Australopithecus afarensis, although some scientists doubt this, and this could be the late surviving genus of Australopithecus afarensis. This thing is still underway. And recently, Professor Zai did make an announcement paper on this one. This is the first appearance of Paranthropus in the Afar. And like I said before, now the Afar, the map is complete, and all the species, the 13 species among the 22 known species have been discovered in the Afar region of Ethiopia. including our own species at 100,000 years, Homo sapien idaltu. That showed you why we considered Ethiopia as much more completer picture of human evolution, and what we call Ethiopia, the land of origins, which is our motto. And when this was also ongoing, I want to slightly show you that research was not made. Everything was not hand in hand, and things were sometimes very challenging. This was the first storehouse for all this fossil specimen, the first lab back in the day. I don't think I was even. I was maybe in kindergarten when this was built. And after that, our government did make a significant contribution and build this lab that you see here. Some of you in this room did recognize this building. The front one used to be the old Ministry of Foreign Affairs of Italy, and at the back is the modern paleoanthropology lab. And this is how they organized the first collections, which made a lot of work, and people dedicated a lot of years and investment in making this happen. This is the current facility. This is the collections in Addis, the paleontological collections. Everything is now neatly organized, as you see here. And this is some of the collections that are well organized. You can see, this is the first wave that in 2011, when the first hominids were moving into the paleoanthropology lab. And this is how things are organized in a very nice cabinets and a very nice safes and things like that. So Lucy's fame have been, very useful motivation, I would say, for the younger generation of Ethiopians, and I would say for all the world, in fact. And a lot of books have been written praising Lucy and how this science is important and things like that. And all these discoveries you see here have been made in the front pages of major journals, which created a lot of impact on tourism industry. And the government did make a dedication and designated Ethiopia as the motto is now the land of origins. Thank you very much.